Hi everyone, this is a short video about how to solve a system of equations by using a method called elimination. The previous video showed a method called substitution. This time we will look at elimination, which is also on occasion referred to as the addition method. And addition is an appropriate way to describe it, because what we're going to do is add these two equations in the system together. And the goal is to get one of the variables to cancel out. In this situation, we're already set if we want to do addition here. If I do addition, right, if I do addition here, the y's are going to cancel out. I know this because the signs are opposite, and the coefficient in front of y, in this situation, right, the coefficient in front of y is 1. They have the same coefficient, but they have opposite signs. And if I add these together, they're going to cancel out. And so what I'm left with is 6x equals 18, which is nice because now I can just solve for x by doing division. And I get x is equal to 3. So I know what x is equal to pretty quickly. What I need to do now is take one of the original equations, and I'm going to use the top one, but it doesn't matter which one you choose. And I'm going to substitute what I know for x into the equation. So I know that x is equal to 3, so I'll put 3 for x. So I get 4 times 3, that's 12. And then I can solve for y by subtracting 12 from both sides, and I get y is equal to 1. So the solution to this system is the ordered pair 3, 1. So again, remember, these are lines, right? These are equations for lines. So this ordered pair is the place where these two lines will intersect on an xy coordinate plane. All right, so that's the method. We just add the two equations together and try to eliminate one of the variables so that we can solve for the other. So let's look at another example. So 4x plus y is equal to negative 13. 6x minus 3y is equal to negative 15. So if I just added these two equations together, if I just decided to just add them, I would get 10x minus 2y is equal to negative 28. And notice that I still have two variables here, which we can't solve, right? We can't solve an equation that has two variables. So what we need to do is we need to make some changes to our equations. So suppose, for example, I wanted to cancel out the y's. It's kind of a good choice. This one's positive and that one's negative, so it's sort of ready to cancel out. But the problem is I need a 3 in front of this y. So what I'm going to do is multiply the top equation by 3. And when I multiply the left side by, I have to do the same thing to the right side. I can't change just one part of the equation and not change the other. So now my system, if I do this distributive property here, my system looks like this. 12x plus 3y is equal to negative 39. And then the bottom equation, 6x minus 3y equals negative 15, that hasn't changed. So what I want to do now is I want to add these together. And if I add these together, I get 18x, and the 3y and the negative 3y cancel each other out, and I get 18x is equal to negative 54. So I've got rid of the y variable. Now I can solve for x by dividing by 18, and I get x is equal to negative 3. Now, taking one of the two equations, and I'm going to use the top equation again, but you can use either one, it doesn't matter. So I'm going to use 4x plus y is equal to negative 13, and I'm going to substitute negative 3 for x. So now I get 4 times negative 3 plus y is equal to negative 13. Negative 12 plus y is equal to negative 13. Add 12 to both sides. Y is equal to negative 1. So the solution to this system is the location or the ordered pair negative 3, negative 1. So again, sometimes we need to multiply one or both of the equations by some factor so that we can create coefficients that will cancel each other out. All right, so it can get a little bit more complicated. So we're going to look at this system, and we're going to solve this system in two different ways, and you'll see why in just a minute, like why I've decided to do this in two different ways. So if I just added these together, I would get 11x plus 2y equals 9. Nothing canceled out here, so I can't do that. I need to make some changes to my equation, my system, so that things will cancel out. So I'm going to look at the y's first, because that's negative and that's positive. So that means if I added them together, they're sort of ready to cancel each other out. I just need to find a number that 3 and 5 have in common, because I need a coefficient that will cancel out as well. And 15 is a multiple that 3 and 5 have in common. So I'm going to multiply the top equation by 5. I'm going to multiply the bottom equation by by 3. And when I do that, what we get, top equation becomes 20x minus 15y equals 35. The bottom equation becomes 21x plus 15y equals 6. Add these two equations together, and we get 41x. The y's cancel out. We get 41x is equal to 41. Divide both sides by 41, and we get x equals 1. So then I can pick either of the two original equations. I'm going to work with the bottom one this time, just to do something a little bit different. So 7x plus 5y is equal to 2. Oops, what happened there? Let's move that. Let's grab the eraser. Not sure what happened there. Let's do this again. Okay. Let's slide this a little bit more like that. Okay, all right. Okay, so 7x plus 5y is equal to 2. And I'm going to plug in 1 for x. So I'm going to do 7 times 1 plus 5y is equal to 2. 7 plus 5y is equal to 2. Subtract 7. 5y equals negative 5. And then divide both sides by 5. And we get y equals negative 1. So my ordered pair is 1, negative 1. So in this situation, we decided to get rid of the y variable, right? And so we got a coefficient that they had in common, and we made sure that they had opposite signs, right? So we got rid of the y. Now, what if instead I wanted to get rid of x? I got to think about a number a multiple that 4 and 7 have in common. That would be 28. One possibility is 28. So I could multiply the top equation by 7, but I'd have to multiply the bottom equation in a way that, I could multiply by 4, but then I don't have opposite signs, so I could multiply the bottom by negative 4. So my equation now looks like this. My system looks like this. 28x minus 21y is equal to 49. And then there's negative 28x minus 20y is equal to negative 8. If I do my addition here, the x's are going to cancel out. And we get negative 41y is equal to positive 41. So the x's canceled out this time. Divide both sides by negative 41. Y is equal to negative 1. So I know what y is. Now I need to figure out what x is. So I'm going to use the bottom equation again, like I did the last time. 7x plus 5y is equal to 2. And now I'm going to substitute negative 1 in for y. So 7x plus 5 times -1 is equal to 2. 7x minus 5 is equal to 2. And then we add 5. We get 7x is equal to 7. Divide by 7, and we get x is equal to 1, which was the same solution we got when we did it to get rid of y. So this time we got rid of x. So we focused on the x variable. We made sure that they had the same coefficient, but that they had opposite signs. So sometimes, you have to consider what you're going to multiply by to make sure that your coefficients are the same, but also have different signs. So that is a very quick video showing the method of using elimination to solve a system of equations.